Hey everybody, this is Intro, and this is the introduction to our C++ programming tutorials. And basically I just wanted to go over what we're going to be using. I'll be using the IDE code blocks, which I'll put a link to in the description, so you can go ahead and go download that. And other than that, this is going to be a series on all of C++, every single little piece of code that is in C++ will be on here. And I'm really going to try to show you an in-depth way to use and learn, and most of all apply the code to different scenarios. So if you'd like to watch, please subscribe and like this video, and I'll see you in my next video. Thank you. Hey everybody, this is the Intro, and in this tutorial we're going to be going over basic C++ output using the IDE code block. So this is just going to show you how to output information to the screen in forms of strings. We'll be going over other outputs later, but for right now we just have strings. So what we're going to use for this is the cout operator, or cout. And for this we need the output operator as well, which is two less than signs. And then after that we're going to have a string of text within parentheses. So anytime we add text to a C++ file, we're going to want to use our two sets of parentheses to denote that there's a string inside of them. And your compiler will automatically pick up, okay, I see these sets of parentheses, and I know that we have some type of user input in the form of a string type. So what we're going to put inside here is just put this. This is a string output example. You can put obviously anything you want inside of here, but just for this tutorial we're just going to use this example. And then after this we're going to want to put the two less than signs again to denote that we're going to be actually outputting another piece of information. And the last piece of information we're going to put is the end line command. So endl is how you display it in C++, and that just basically means, okay, I'm done with this line of this string of text, and after it I want to end the line so that anything else I put after this will be outputted onto the second line or the next line that precedes that command. So after that we just add the semicolon denoting that we have we've ended our command. So at the end of each C++ command we always have to have a semicolon. Very important. It's the thing that tells the compiler to stop running this line of code. So that's all we're going to put inside of here. Of course we could have obviously just put the semicolon here and then just deleted the end line. That would have been fine too, since there's nothing below this to really put on that second line. That would have been fine, but for now we'll just leave it like this. And we're just going to go up here and click build and run. Now as you can see here we got the our command prompt window that opened up with our program, and it says this is the string output example, which is exactly what we wrote up here. So that's how you do basic output, and I'll see you next time. Hey everybody, this is Intro, and in this tutorial we're going over C++ input. So to create an input, we have to have something to store that input in, being that this is a program, right? And we have our main function, and inside this function we have to have some way for the user to store information. Since there is no other way to store information written in here, what we have to do is create operators that will store that information for us, otherwise known as variables. So variables can be used in C++ to give objects names, to declare what an object's going to do, a bunch of things. But for this we're just going to make a variable that's going to be used as some sort of memory. So what we need to do that is, there are many types of different variables that can be used, that can be used within C++. So there's float variables, there's integer variables, there's string variables, but what we need to do for this is just create a simple variable for strings. So to create a string variable, what we're going to do is type in string, which obviously you can see the syntax of it automatically changed, just to note that this is a variable. After we type in string, we're going to want to give our string variable a name. So your name can be anything. I'm just going to say first string. And then after this, we want to end our command, denoting that there is no value for first string. Now what we could have done is put, or deleted the semicolon and put equal to, and then put the parentheses and our semicolon again to end the line, and then just enter some value inside of here to denote as the value of first string. So when you give this a value, say we say example 1. Now the example 1 string is what is stored at the memory address of first string, if that makes any sense. So when I go to output something now, I can see out, put my output operators, and just type in first string, and we'll go ahead and end that line. Now what this will do is it's just going to output the value of what first string is. And since I set the value of first string to example 1, it's just going to simply output example 1. So we'll go ahead and test that. And here we go. So you got example 1 right here that was stored in this first string variable and then called by me to the screen using its name that we gave it. So that's how you call a string variable, and next we're going to be going over how to store a string variable. So we're going to want to delete all of this, the value that we gave first string, and we're just going to put the semicolon as I said before. And what we're going to do is we're going to say, okay, instead of, so when I have a variable of string that I want somebody to input, there has to be some way of telling that user, okay, I have a string variable, will you please enter something that I can store in it? So what I'm going to do is I'm going to output store a variable, or actually store a string variable to the user. So after the user sees store a string variable pop up, they're going to say, okay, I'll write in a string variable for you. So what this operator does is it actually allows us to store some value that the user inputs into a variable. So this is the input operator, so that means that a user can now input information, and this uses the two greater than signs. If you've noticed, this output operator right here is sort of going out to the user, and then the input operator is coming in back into the computer. That's another way to remember that. So what we're going to store that variable in is going to go here. Or what we're going to store, what the user is entering in, is going to go into our input operator. So I want that user to store their information in the first string variable which I created at first. So to do that, we just enter first string and end that command. So after this, the user is going to enter a input and it's going to be stored here, and I'll show you right now. We're going to click build and run. Okay, so it says store a string variable. Notice that the string variable that I created didn't pop up on the screen because it wasn't outputted. It was just a part of the program that we're using to store something to its memory. So what we're going to do is the user is going to then see, okay, store a string variable and input something. So this is my string variable. And then they just click enter, and that's the end of that program. As you can see, what this program did was it took that input and it stored it into first string. You didn't see that, but when the user inputted, this is my string variable, it was stored into here, and we can show you that by exiting this command prompt, going back over here, and actually just putting the cout or the output operator again, and then outputting first string. Now, as you can see in our program, first string was not given any value. It was I simply asked the user to enter some value in the form of a string, and they entered that value, and now I'm just going to output that value back out to them. So before we output this to the screen, we're just going to say this is the value that you entered, or you've entered, and then just put a colon, and then I can just use my output operator and put first string. And in that line, you'll see why I gave this the colon and some space here in a second. So we're going to go ahead and run this program. And here we go again, store string variable, C++ programming. Click enter, and this is what we got. This is the value that you've entered, C++. And the reason why it did not store the second word is because we didn't take. So when you have when you have a user input some value, the string has to be stored in one word. So like when I called this first string, what it took from that C input was the first value that I grabbed from it. And we'll go over later why it does that and how to get around that, but for this video it's just something that we don't really need to go over. So I can just go back, rerun it, and I'll just put like C++ programming all in one word just to show you guys. So C++ programming, enter, and this is the value that you've entered. And since it's all in one word, we got the exact same value that was entered. So that's basically how you input or have a user input some values to the screen. Thank you guys for watching, and I'll see you in my next video. Please subscribe. Hey everybody, this is Intro, and in this tutorial we're going to be going over the different types of variables that we can use within a C++ document or program. So just a quick note, when you start C++ or code blocks, you get this console application. It's the last thing that pops up before you create your actual file for the program. We don't need the create release configuration, so I would leave that unchecked for now. Just a quick tip. Alright, so we're going to start by actually going over all of the different types of variables. So the first thing we're going to go over is how to store one type of character. And actually, before I go into this, I want to explain really fast what a variable is. It's just a piece of our identifier that identifies what type of values that is going to be entered into your program. So you'll see as we go along. So to store one character, what we're going to use is the char variable. So this is used to call one character into a C++ program. You could use it for multiple reasons. After every variable, we want to give it a name. So you can name it anything you want. You just want to have a specific name for that variable, and remember that the names for the variables are case sensitive, so remember to always further on down the course, when you're outputting your variables, always use capitalized letters where they're needed and uncapitalized letters where they're needed. So I'm just going to name this example. And after that, we put the equal sign to set it equal to something. And we don't use double quotes, we use single quotes. And we just enter a letter. So I'll just put I. And then of course we end our statement. And if you didn't know, we end statements with the semicolon. So after that, we basically created a variable of the type char, which means that we can store one character in it, and we've stored the character I. And to call that, we're going to use the name example. So just to give a quick demonstration, we're just going to cout example, which is our character variable, and end that command, and then build and run our program. Alright, and you see I. I'm not going to do this every time for every single variable. I'm just showing you how it outputs and everything. We really don't need to go over output in this video. I have another tutorial on that, and I'll actually put the link for it in the description. But next, we're going to go to string variable. So what a string variable is it's simply typed in a string, and it stores any type of sentence. So we can store paragraphs, we can store single words, just any type of string. And to do that, we just type string, and again give it a name. So string example. and set it equal to something. But this time when we set it equal to something, we have to use double quotes. This is always used when we're signifying a string variable. So inside the double quotes, just enter whatever you want, and I can just put this is a string variable, and that's the end of our string variable. So string variables are used to store sentences, paragraphs, or words, and characters are used to store single letters. So next we're going to move on to actually our arithmetic or our number storing variables. So these are the variables that we use to store characters and strings, and the next set will be used to store numbers of all different types. So what we're going to go over first is the first variable that you should know, because our main function is called it, and it's int. So int, which stands for integer. So for integers, we can store basically any whole number or natural number. So after int, we can just give it a name. So I'll just put whole number and set it equal to a whole number. We don't need to put any parentheses when we're storing any type of number value. We just enter the number and then the semicolon to end this statement. So put the semicolon, and our whole number will be 55. Next, we're going to go to float variables. So what a float variable is, so what a float variable is it can store decimal values. As an integer variable wouldn't be able to store a decimal value, floats can. So that's the only difference. So let's put decimal value and set it equal to 67.7867, and of course and that's how we create a float variable. And just if you wanted to go through, you could actually just go through and output these with the cout command, just to make sure, just to get a deeper understanding of what's going on. But the next variable we're going to go over is double, which is basically like the float variable, but it stores a little bit more information. And I actually put a link in the description to the actual C++ web page that will show you exactly the values that it can store, which really, when you get into a high software development and stuff like that, will matter. But for right now, it really doesn't matter. All you really need to know is that floats store decimals, double store decimals, integers don't. They store whole numbers. And for the double, we can just name this decimal 2 and set it equal to 3.14 and end that command. So next we're going to go on to long double, which again is just a longer form of the double, which means it can store a specific amount of variables, or not amount of variables, but a specific range of numbers. And again, I will put a link in the description to that exact value. But after we enter long double, we're just going to again remember to put a space right here when declaring this variable, and name it. So just name it L double and set it equal to, and then close our command. So these are basically all of the variables that we can go over as of right now. So as we go in to a more in depth, we'll go over different variables. For right now, these are the ones that you need to remember, and remember them perfectly so you know when to call them and when not to. So thank you for watching, and the next video that I'll be making is actually going to be on functions and prototyping, so please subscribe, and thank you for watching. Hey everybody, this is the intro, and in this tutorial we're going to be going over how to make functions in C++. So basically, to make a function in C++, if you don't know what a function is, it's basically a place where we can put our rules for our program. So if you think of a huge game or something, you have all these different variables and all these scenarios that are going on. All of those are programmed into different separate functions. So if I have the character and what the character looks like, and I have the movement of the character. All these are going to be different functions. The guns, the some of the vehicles in there, all of those are going to be ran through different functions. So to make different functions in a program, what we're going to do is we have to make some type of type. So we see right here that we have an int main, and this is our main function for our programs in all C++ programs, and this is where all of our program prototypes or our function prototypes must be ran through in order for them to work, because everything written outside of this cannot be called into play without it being written somewhere in our main function, which is what we're going to get to later. It's called prototyping. So first we need to learn how to make a function. So to make a function, we have to understand the function types. One is integer and one is void, and there's other types of functions that we can create, but for now those are the two that we really need to know. So for the integer, we have to have some type of return value. So since we're really not trying to get a return value in this scenario, we can just use void for basically all of our functions. So what we're going to do is type in void, which means that we don't want a return value, and then we're going to type in the name of the function. So say, and you can name your function anything. So I'm just going to name this function 1. After you type in the name of your function, you're going to have to type in parameters, just as in the int main function. And we'll talk about parameters later. You don't need parameters for functions. It's just something. So if you have a set of variables that are dedicated to a certain function, we can use them as parameters and pass them through that function just to make things a little easier, but again, we'll go through that later. Next, we're just going to write the body, so 2 braces and then give it some room. So in function 1, we can write anything. So say I have a string called name and it's equal to intro, and I just end that line, and then I just see out my name if I can type. Alright, so see out name, and of course you know what this is going to do. It's just going to print out my name on the screen, and we go to run this and build and run it, and we get nothing up on the screen. And the reason for that is because the second thing I was talking about, it's prototyping. So for this function to work, or this set of rules to work in our program, it has to pass through the main function. Like I said earlier, without it passing through the main function, it might as well have not been programmed. So everything must pass through the main function in C++. So to make sure that happens for a function and this set of rules inside the function, we use a prototype. In the prototype, we just simply type in the name of the function, and as you can see, it popped up right there. You just type in the name, you type in parameters, and you just end that line or end that command. And this is the prototype for that function. So whenever the compiler is going down the program and it sees this function, it's going to look for the prototype in the main function in order to call that set of rules. So just to make this more clear, we'll go ahead and run this again. And as you can see, intro, it popped up. And that's basically how it works. So you can create multiple functions. It doesn't matter how many you create. And we can just do the same thing. We can have int x is equal to 5, int y is equal to 6, and cout x plus y, and in that line. And what we'll do is we'll just prototype that function instead. I could of course just go like this and prototype both of them to run, and just maybe end the line between both of the functions, and after, just so that it gives it some room. And we can just run this function, and it'll run, of course, function 1 first, so my name should pop up first, and it'll end a line, and then function 2 and its set of rules will pop up, and it should see out x plus y, which should be 11. So we'll do that and see what it looks like. So build and run, And as you can see, function 1 ran as it was called into the main function, and it ended that line, so it didn't print it on this side. It ended the line and started a new one, and then printed out function 2, which was x plus y. So that's how you build functions and prototype functions. We'll be using them a lot, so make sure you have a thorough understanding of how to use them. And other than that, thank you guys for watching. Please subscribe and like, and visit my channel for more videos. So thank you. Hey everybody, this is the intro. In this tutorial we're going to be going over arithmetic and arithmetic operators in C++ and how they're used. So what we're going to do first is create a few variables. So we're going to want to set 2 number variables. You can give it whatever name that you want. I just named mine x, and set it equal to some whole number, because we know that integers can only be whole numbers. So we're just going to set this to 88, and we're going to create another one and just set that equal to 45. Now to do the arithmetic, we're just going to see out, and as simple as can be, just use x plus y. Once you do that, just end that line and in the command, and it'll add these 2 integers together. So we're just going to build and run, and here we go. So the answer is 133. So you can use different variable or different operators, such as the minus sign, and there's just as you think they would be. They're just the minus sign, and then multiplication sign, and then the forward slash for division. So say we were to do x divided by y, so 88 divided by 45, and build and run the program. What we got was 1, and the reason for this is because we can't store decimal values into our program using the integer values. So x divided by y can't be done, because when I stored 88 into our variable int, it said, okay, I have a whole number, and the same thing for 45. So they know that the answer that they can give back can only be of a whole number, so they gave back 1. So to change that, we can do float, which, as you've seen in the other variables video, floats can store decimals. So float, and we'll change both of those, and we're going to run this again. So x divided by y, build and run, and there we go, 1.95556. We got the answer, because floats can store decimals and integers can't. So basically that's how you do arithmetic. It's very simple. It's something to get used to. We're going to be using it a lot, especially in loops later on. So thank you for watching. Please subscribe, please like and comment in the video if you have any questions, and thank you for watching. Hey everybody, this is the intro, and in these tutorials we're going to be going over the if and else statement in C++. So to use these statements, we're just going to basically use the if command and the else command. But before I write those, we're going to go over the if command and what it is and what it does. So basically, an if statement runs some sort of test, and that test is written inside of these parameters. So right after we declare our if statement, we have to have a set of parameters. Now inside this parameters is some type of test, and it can either be true or false. So what we can do, or what we do after this, is of course we're going to add a body of code. So inside of this body, actually I'll move this down a little bit just to give it a little room to read. Inside of this body of code, we write what is going to happen if this is true. So only if the if statement inside of this parameter is true will it run whatever we write down here. Now in order for an if statement to even be called, we have to have some variables or some type of test or testing sequence to go on. So what we're going to do is create 2 float variables. So I'm going to create a float variable of x and of y, and just give them just arbitrary values, and we're going to go back down to our if statement. So in our if statement, we have a test again in these parameters, and it can be true or false. So what we're going to want to test within this program is if x is greater than 23. So we could just say fx is greater than y. So what we're going to do is just say if, and then run the test, x is greater than y, then cout congrats, x is greater than y, and just end that line. And again, this is just for an example. So we're going to end that line, and so if x is greater than y, it will run this code, which we know x is greater than y. When we're using user input and the user is entering these values, of course, it would be something that the user, or not the user, but the programmer didn't enter, so these values would be different depending on what the user inputted. But for now, we've declared the values up here uniformly, so each variable has a value. So fx is greater than y, and we know it is. It's going to run this test. Else is used right after our if statement. So else means if x isn't greater than y, then we're going to run this set of code. And again, the else statement needs its own body of code. So just a quick hint, we can, if we highlight these brackets, it'll show us where if statement body starts, where else statement body starts and ends. It shows you the start and end of each of the command or any type of object body that you create. So even for the main function, this is the start of the main function, the end of the main function. Just something to know, just because when you have a whole bunch of these, it can get sort of confusing. So in our else statement, so if x isn't greater than y, we're just going to say you lose, x is not greater than y, and in that line. So we're going to go ahead and run this code and see what happens. So we should get this first line of code because we have a true value. So we're going to build and run it. And there you go. So congrats, x is greater than y, because x was greater than y when I declared the value. Just another quick thing that we can go over, we could also have the user input some values for x and y. So just delete what the values were for the float x and y. And for this, of course, we're going to need some type of input operator, which is a cin, and then our input operator after that. So we're going to have the user store a variable in x and a variable in y. And before that, we're going to prompt the user to enter two values. Okay, so the user is going to take in or get this piece of information. Actually, I forgot to end that line or even end that command. So the user is going to see enter two values, and it's going to take in them two values. After that, we're going to see the either congrats or the you lose, depending on if the statement that they entered was true, determined by this test, or if it was false, determined by this test. So if it's false, we'll get this. If it's true, we'll get this. So I'm going to click build and run, and here we go. So enter two values. My first value is going to be stored in x, so I'm going to put 67 and 107, and there you go. You lose, x is not greater than y, because we gave a 67 value for x and a 107 value for y. So our else statement ran instead of our if statement because we got a false statement or a false user input. So that's basically all we're going to do in this tutorial on if statements. Later on we'll go into more depth on what if statements can be used for and different operators that can be used around it. But for now, that's all we're going to go over. So thank you for watching, and please subscribe. Hey everybody, this is Intro, and in this tutorial we're going to be talking about comparison operators. Basically what comparison operators do is they give us some way of testing a result. So what we'll do is, what we're going to do is actually we're just going to create a if statement, and we're just going to say if x is equal to 1, then you win. Next, what we're gonna, okay, actually I just found that, let me fix this really quick. Okay, so fx is equal to 1, we're gonna see out u in. Obviously x is equal to 1, so when we run this program, we will get u in. And I forgot to put a quotation mark. Okay, so run it again, and we should get u in. Okay, close that out. Now, what a comparison operator is it's basically what this same thing right here is. It's some way to compare this value to this value, or one value to another. So basically the different types of comparison operators is equal to, which is this one, and there's not equal to, which is the exclamation mark in equal sign, which means fx is not equal to 1, then see out u in. So obviously this is false, so when we run it, we will get nothing. So we get nothing right here, and that's not equal to. So our next comparison operator is greater than. Fx is greater than 1, then run this program. Then of course we have less than, which is used traditionally just like greater than, and so this means fx is less than 1, then run this code. And then we have our greater than or equal to, and our less than or equal to. So the way you write these is that the equal sign is always on the right side. So greater than or equal to is written like this. So fx is greater than or equal to 1, then run this code, which of course we know is is true because x is equal to 1. So the other one is less than or equal to, which again you leave the equal sign on the right side of the operator or the value. So leaving it like this, we know that x is or is not less than or equal to 1, or it is less than or equal to 1, my bad, sorry about that. So x is less than or equal to 1, so when we run this, we'll get the see out u in command again. And basically those are our operators. So remember, we have the equals, which is written like this. Then we have the not equal, which is written like this. And then we have greater than, we have less than, then we have less than or equal to, and greater than or equal to. So those are our comparison operators. Thank you guys for watching. Please subscribe, please like the video. If you have any questions, please post them below, and I'll see you next time. Hey everybody, this is Intro, and in this tutorial we're going to be going over for loops. So what a loop is it's something that runs recursively over and over again. And this is very useful in a lot of different scenarios, so it's very useful. I mean, not useful, but it's very vital to learn. And so what we're going to go over first is how to declare a for loop. So for is what we declare it with, and after that we have parameters and a body. So in our parameters, we're going to have 3 different things that go in here. The first one's called an initializer, and that's separated by a semicolon. All 3 things in here are separated by a semicolon. And then our second one is our test expression, and our third one is our incrementer. So to go over this, we have a loop that's going to run over and over, and it's going to run over and over based on these 3 things. So our initializer to start with is where we're going to start within that loop. So we're going to create some variable and set it equal to a value of any value you could set it equal to, but we're just going to start it to 0 for now. And our test expression, of course, separated by a semicolon, our test expression is going to be, we have a initializer, which is a start for the loop at 0, and we have to have some place or somewhere that the loop ends so that it just doesn't keep going on and on. Of course, we could make it go on and on, but in most cases you're not going to want to do that. It could crash your code blocks IDE and just create all types of problems. But for our test expression, we have to have some type of value. So what we're going to do is type x is less than 10. So this is our test. So we have, so far, x is equal to 0, and is basically what this says, as long as x is less than 10, and then our incrementer is what keeps, okay, so we have a 0, and we have to have some way for our integer of x to become 1 and 2 and 3, and that's where our incrementer comes into play. So what our incrementer is used for the syntax is the variable's name, so x, and then plus plus, which means plus 1, meaning that every time this loop runs, it will change this 0 value from 0 to 1, from 1 to 2, from 2 to 3, and so on until it equals to 10. So when it equals 10, it will stop because x is no longer going to be less than 10. We could also use less than or equal to 10 to get an extra so that we get 10 values outputted to the screen, or 10 recursive functions that run, because anything that runs inside of this body will recursively run over and over and over again, if you get what I mean. So I'm trying to overcomplicate it for myself. So without trying to overcomplicate it, I'm just going to put cout, and we're just going to cout error, capital letters a whole bunch of times, and in that line. So our for loop is called into play. We have our initializer, x is starting at 0. Our test is as long as x is less than or equal to 10, and our incrementer, which is x plus plus, which means every time this loop runs, it will go up 1 so that we get 10 eventually, so that our loop will stop. So you should see this run 10 times. So we're going to go ahead and build and run our program and see what the for loop does. So as you can see here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. And the reason we got 11 instead of 10 is because in programming, 0 counts as an object. So when this compiler was running this code and it said, okay, you started at 0, it took 0 as an object. Not like in normal math or normal algebra. It does recognize that 0 is an actual object. So it started at 0 and counted this as one object and entered that first line, and then it went to 1, 2, 3, 4, 5, 6, and all the way up to 11. So that's just a quick tip, and that comes in a really big play when we are creating loops, because say I needed 10, and you just went in, started at 0, and entered 10, and you're expecting it to get 10 values back. You're not going to. And if I was to take this equal sign out, it would mean x is less than 10, so it would stop at 9, so we'd get 10 values exactly instead of 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as you can see there, it didn't count 10 exactly, because once 0 reached 10, it stopped being less than x, or 10 stopped being greater than x. So that's how you run a for loop. Remember the syntax for them, remember how to use them. They'll be very useful in the future. And actually, I'm going to go over a few things, or one more thing. So we don't have to declare this inside of our for loop. So I can actually just delete this part of our loop, and we can just say, so integer x is equal to 0. And I don't mean that by you can't have that at all. You have to have an initializer, but we don't have to actually declare that variable inside of it. We can just type in the name. So of course we still need the variable type, or actually we don't need the variable type, I'm sorry, I didn't mean to say that, but we need the variable name. So we're starting at x, give it a little room. So we're starting at x, and instead of declaring int x is equal to 0 inside of the for loop, our program knows x is equal to 0 because that's what it was set as. So this basically says the same thing as this, if you get what I mean. So for x is less than 10, x plus plus, and run our program again. And as you can see, it runs perfectly just as it did before. And that's basically how you use for loops. Thank you guys for watching, and stay tuned for my new videos, and please subscribe. Hey everybody, this is the intro. In this tutorial we're going to be going over the while loop. So for a while loop, it's sort of like a for loop and sort of like an if statement. So for the while loop, we enter some sort of test into the parameters. First we'll get it written down. So while pair of parameters and our body, give it some room and go inside the parameters. So what I meant by it's sort of like the if statement and it's sort of like the for loop is that we can have multiple values just as the for loop. So I can have some loop that starts at some value and it loops until the test is false and runs this code until the test is false. But we can also just test one value. So if I just want to test if x is less than 10, so while x is less than 10, and I'll actually just create a variable x up here and put it as 3 or 3. So then in that command, so while x is less than 10, we're gonna say while loop, and that's just gonna be outputted to the user. Okay, and next what we're going to do is we see that there's again a need for an incrementer. As you've seen in the for loop, there's a need to increment this value of x so that this while loop eventually will end, because look what happens if I just click build and run. We just get a continuous stream of while loop or whatever the test was, because x was set to 3 and it doesn't have an incrementer. It's never going to be anything else but 3, so it's always going to be less than 10. So to stop this from running, we can just click Control C, close it out, and add an incrementer to this. So I want to add the incrementer, and instead of adding it in our parameters up here in our while loop, which we could use with our comma. So instead of using a semicolon as we do in for loops, we use commas in the while loops to separate everything. So we could just say x plus plus right here, but another quick way to do it is to just put it in the body of the code. So I can just put x plus plus, remember it's case sensitive, and that x plus plus equals x plus 1. So while x is less than 10, and we gave it an incrementer, so every time this loop runs, it will then increase 3 to 4, 4 to 5, 5 to 6 until it equals until it equals 9. It won't reach 10 because it has to be less than 10 for it to be true and for this code to run. So we're gonna run this code and see what we get. So build and run. And there we go. So 3 was incremented until it was less than 10, which is 9, and then it stopped. We could also say is less than 100. Build and run it again. and there we go, we get 100 of the statements that were inside of the while loop's body. And that's how we run a while loop. So we can run any type of test in here, and it will run until that test is false. And the next video we'll be talking about do while loops, which are just sort of the same as while loops, but have a little perks to them, and sometimes can be easier to use in certain places. So thank you for watching. Please subscribe and like the video, and I'll see you next time. Hey everybody, this is the intro, and in this tutorial we're going to be going over the do while loop. So what the do while loop is it's sort of like the while loop, but it has a little bit of different syntax to it, and we'll go over that right now. So what we're going to type in is do and a body of code, and this is our the do part of our loop. So after this we type in while and a set of parameters and a semicolon to end the statement. So this is the syntax for a do while loop. Basically what this is it's sort of like the while loop, but instead of just running the code over and over, it's sort of like a it's sort of like a easier way to do it. So we can do or run this set of code while these parameters are true. So when these parameters aren't true, we're going to stop running that code. So for example, if we have cout x plus or x minus y minus z, and we just have some variables, integer x is equal to 5, or let's just put 500, integer y is equal to 200, and integer z is equal to 6. So basically what we're saying is, okay, do this or see out this arithmetic operator while some test is true. Now, as we learned before, you cannot declare initializers inside of a while loop. They have to be declared somewhere else. So we're going to go ahead and declare our initializer, and I'm just going to name it in, close it out, and we're going to say while in is less than or equal to 150. I want to keep doing this operation and sending it out to the user. So we're just going to put an answer, give it some room, and in line after the calculation. And there we go. So do this code while in is less than or equal to 150. Now if you're thinking about it, you're thinking, okay, in doesn't have a value. Obviously you have to give it some type of value. Sorry about that. So in doesn't have a value, we're going to set it to 0. So in is equal to 0. While in is less than or equal to 150, we're going to keep running this code. And of course we need an incrementer so that it can eventually reach 150. So after we declare our in variable, we're just going to say in plus plus and use the semicolon to denote that we're done with this command. So what we're going to do is go ahead and run this. Just give it a second here. Alright, there we go. So what we're getting is answer is 294, and the variable in is incrementing every time by 1. So it'll display this answer 151 times, because remember 0 is an object. But as you can see, it doesn't stop. And the reason this doesn't stop is because it said, okay, in is equal to 0, because remember the compiler reads from top to bottom, and the initializer went, so it said, okay, it has a way of initializing to equal 1, but it's not inside of our while loop, so it's not going to keep incrementing, if you get what I'm saying. So the loop isn't running this function, therefore it's just going to do it once. So what we're going to want to do is just close this out. We're going to take this incrementer, delete it from here, and then put it inside of our while loop parameters. So we're going to have while, comma, and then in plus plus. And of course we don't need that semicolon. And what this will do is it'll say, okay, every time this do while loop runs, it's going to keep running and keep running and keep incrementing, instead of writing it outside of our loop where it would only increment it once. So this would be good if we were doing something else. So I'm going to show you this answer first, and then we'll go over something else. So build and run it. And there we go. So the answer is 294. And the reason we are getting this answer actually is because this has to be declared outside of our parameters. So sorry about that again. I'm really clouded right now. So in++ has to be inside of our do, because the do part of the code is what the compiler is actually going to keep doing over and over, and the while is just the operator that says until we reach some point in our test, then we're going to keep running this code. So put the in++ inside the do body and leave while as it was, and then just rerun that code. So I'm just going to close this out and build and run it again, and we should get the perfect program, which should be 151 outputs because 0 is an object. So as you can see, it ran, we got our 151 answers, and there was nothing wrong with our code. And the last thing I want to show you is that we can actually increment anywhere. So I'm going to delete the while or the do while loop really fast and just show you something really fast. So if I take I or any integer value or any number value, I can increment it, and while the compiler is reading it, it won't increment the actual value until I display the incrementer command. So I'll show you right here. So we have just one simple integer, and we're going to see out that integer. And actually I'll just write in here integer, give it some room, and we're just going to output 0, okay? So after we output 0, I'm going to add an incrementer for that variable. And then after that incrementer, I'm going to go back and I'm just going to output that integer one more time. So integer after incrementing, and we'll just do the same thing, enter the name of the variable and in the line, and run this code and see what we get. Okay, so as you can see, the incrementer took this value and added 1 to it, but only after we declared our incrementer variable or command. So when our compiler was reading, it said, okay, we found an integer in that's equal to 0, and we're going to output that to the screen. So it outputted 0, and then after that added the incrementer operator to add 1 to it, and it said, okay, now you've changed the value of in to 1, since in++ is equal to the initial value plus 1, and we got the value 1. So 0 plus 1 is 1, and we can keep doing this. So I'll just show you one quick more time, because this is really important, incrementing and understanding how these values coincide with one another. Sorry. So integer again, and we'll just give it some room, and in the line. Oh, actually we have to put the variable in there, and in the line. So we have another increment, and we're going to build and run it. Okay, so there we go. So we get our first value, our initial value, after the first incrementation, what happened, and then after the second incrementation, what happened. So after the second one, we got a different value again, which was 2. So that's basically how do while loops work, and a little bit on incrementing. So thank you guys for watching. Please like and subscribe, and I'll see you in the next video. Hey everybody, this is the intro, and in this tutorial we're going to be going over arrays. So basically what an array is it's a value or a storage data type that we can use to store multiple values or integer values at once instead of declaring one by one. So for instance, if I had an integer x that was equal to some value and an integer y that was equal to some value, instead of putting these two things in the same or on different lines, we can put them on the same exact line. So what we want to do this is just to go and create an integer variable, name it whatever you want. I'm just going to name mine array example. Then next we want to add these brackets, not curly brackets, just regular brackets. Inside of here we're going to put the number of items that we want to store. So we want 2. Now I'm going to put equal to, and we use the braces and a semicolon. So this is the basic outline of an array. You have your data type, we have our name, followed by a bracket saying how many integer values are going to be stored in this memory address, and then we set it equal to a set of braces with the semicolon at the end. And this is the syntax for all arrays. So what we're going to do next is put 2 values inside of these parentheses, and each value has to be separated with a comma. So 2 integer values would be 88 and 92. Okay, so now we have an array, or some type of memory address called an array, that has 2 values, one being 88 and the other one being 92. So what we do with this is, when we go to cout, we have to enter the name of the array, we have to enter the braces, and we have to enter which number we want, 1 or 2. So do I want to display 88 or do I want to display 92? And the way this is denoted is, if you remember before in arithmetic, 0 is counted as an object. So when we start counting, we're really counting 0, 1. So 88 takes the place of 0, 92 takes the place of 1. Even though there's 2 elements in the array, we have to call 88 by 0 because that is our zeroed object, or our zeroed value. So when I put the name of the array and I put 0 and I end that line, what we're going to get is 88 out. So we're going to build and run that. And as you can see, we got 88. So this is how it, like I said, this is how it goes. When you have declared some array, you can declare as many variables as you want. Say we wanted 5 different variables that were type of integer, and I just entered a whole bunch of random values. So now we have 5. This 88 is still going to be denoted or called using 0. The 92 is going to be called using 1. The 345 is going to be called using 2. So as I can show you right here, if we go ahead and cout array example and we put 1 and end the line, we should have 88 on first line and 92 on the second line, because that's the place that they come in. So if you can think of it as something like this, as to make it a little bit more visual. So we have 0, comma, 1, comma, 2, let's fix this a little bit. Okay, so we have 0, 1, 2, 3, and 4. So there are 4 objects, 0, 1, 2, 3, 4. But when you start counting, you have to start from 0. And that's really I just tried to get that across because it's really important. So once we have that down and you know how to call arrays, you're basically done. So we have cout array example 0 and 1, and we're going to see if we get 88 and 92. Okay, so there we go, 88 and 92. And we can do this for every single one of these if we wanted to. So we could do this for every single one of these if we wanted to. You just have to call this, say we copy this line of code, paste it again, paste it again, paste it again, since there's 5 objects. and we could just call each object by its number and run. And there we go. So 88, 92, 345, 345, and 234. So that's all with arrays. Thank you guys for watching. Please subscribe, please like, and have a good day. Hey everybody, this is the intro, and in this tutorial we'll be going over actually writing files, or writing strings to files. So basically what we need for this is a new header file. So we'll include an object called fstream, and we want to include the string header file, so that the string header file will allow us to actually save that string, create a string, and save it to that text file or whatever type of file that you want. And the fstream header will actually just allow us to take a file on our computer and save this string value to it. So what we're going to do is go into the body of our main function, and we're going to create an object called an ofstream object. And what this does is it grabs the file, or creates a file on your computer, so that you can append some type of string to that file. So what we'll do is we'll say ofstream, and we'll give it a name. So file out. That'll be the name, and then directly after this you want to put quotes, and inside the quotes, inside the parameters, you want to put double quotes and put the name of the text file. So we're just going to put new text file .txt. Remember to add the file extension, and then we're just going to close the statement. And then what we're going to want to do is create a string, and we could put name and just close it off, and we could ask the user to input some value for name. So just enter your name and give it some room, and they're going to input their name. So next what we need to do is, up here we created the ofstream object, and that was named fileout. And this object, as I said, was used to create a file. And now what we have to do is actually append that name that the user entered to that file. And to do this, we use our insertion operator. So what we use is fileout, which is the name of the object that we created, and the insertion operator, which is 2 less than signs. So that's basically how we do it. And then what we're going to do is, since we had a user input, we're just going to add the variable that the user input was saved under, and then close that command. So now we have this file, or this user input by the user, and that was actually given to this ofstream object. And now the object for the ofstream, or that file, has this data. And we could do this, of course, for calculations or anything. And then basically all we're going to want to do is just cout, and then put contents of file, give it some room, and we're just going to put the name of the ofstream object again, and then in that line. So after we appended that data to the file out, it now has all this data, and it should output it right after the contents of the file. So what we'll do is run this program, open it, says there's something wrong, and quickly let's see, so okay, I didn't put the L, so at the end of N line. So, oh, and actually another thing. Once you're done with this, what we're going to want to do is take file out and close it out. And to do this, we type in the name, put period, and then type in close with some empty parameters. So that's just another hint. So when you're creating a file, you want at the end of the program that file to actually close and save itself to the computer. And to do that, we use this close operator, which is a good thing to know, because this comes in handy a lot during programming. So since we have our header files already and our input operator, and it's going to be saved to the file, we can go ahead and run this again. And there we go. So enter your name, intro, and content of file, and it gave us the memory address for that. So file out, and what we're gonna want to do is, okay, so we have this object, file out, content of file, and actually for that we just enter the contents that the user inputted. Sorry about that. So what we want to do is just insert, to display it out to the screen, we just want to insert that variable that the name was saved under, and we'll run the program again, do the same thing, and there we go, contents of file, intro. And just to double check, we'll go to our search, and we're going to search for the new text file.txt. So new text file.txt, and this will search everywhere on your computer. And there we go. So we can click on that, and here we go. It popped up right in Notepad with the contents that we wrote to that file. And this can be used to manipulate all types of things within your computer, which we'll be going over later, so be sure to stay tuned. Thank you guys for watching, and be sure to subscribe, and have a good day. Hey everybody, this is Intro, and in this tutorial we're going to be going over a thing called constant variables and a thing called size of command. So what we're going to first do is the constant variable. So what a constant variable is, it's something that can never be changed, and to declare it we use the const, or C-O-N-S-T, and we declare what type of constant we want. So we're just going to declare a float, and we're going to give it a name of a number. So we're just going to declare some float number, and of course just because floats can store decimals, we'll just store a decimal into it. And that's basically how you store a constant variable. Now what these are useful for is later on when we go over vectors, and how we can actually go back through variables that we've declared already, and we can change them. So if I had a float and I needed it to be a integer, or if I had an integer and I needed it to be a float, a vector would actually allow you to change that in a specific way, and we'll go over that later. It's not really important right now, but for a constant you declare it like this, and you give it its variable type and the name as usual. And next we're just going to do the size of. So size of will give us the actual memory size. So every variable has some type of memory size to it. So when you save, or when you're creating these variables, an example for number 1, we're actually saving this value to this, and that takes some type of memory from your computer, from your program to do. And that memory size can be displayed by using a thing called pointers, but it can also be displayed using a thing called the size of command. So what we'll do is type in size of, a set of parameters, and we'll actually just end the line, and inside these parameters of the size of command we're just going to enter number 1, and that'll give us the size of that variable. So we'll just go ahead and run this program and see what happens. So we're going to build and run it, and there we go. Memory size is 4. Now what these are stored in is bits, so it's 4 bits that the number 1 is taking up, and we can do this for all types of variables, and it's very useful when you're dynamically allocating memory addresses, which we'll also get into later with pointers, and go into depth more about that. So if you want to go to those videos and figure out more about what constants are and why they're used and vectors, you can go ahead and skip to those videos in the playlist. But for now, if you're just trying to go through it normal and learn C++ and just to keep going the traditional way, I recommend just keep going through these videos in order because they're pretty much from the bottom up. And that's it. So thank you guys for watching. Please subscribe, like, share with your friends, and that's it. So I'll see you guys next time. Hey everybody, this is the intro, and in this tutorial we're going to be going over something called switch branches. So what they are is it's something that sort of lets you not have to create so many if and else statements. So if you remember if and else statements, they can get sort of redundant. You know, if this value is true, run this. If this value is true, run this. Instead of doing that, we can just create something called a switch. So before we do that, I'm just going to start a new voided function, and I'm just going to call it function 1 and no parameters. And we're going to create some output for the user. So what we're going to do is have the user enter some type of number, and save their number. And what we're going to do is actually, okay, so once we have their number saved, we have, like I said, in the if statement, we had if statement, and then we could have a test and a body. This is in switch branching, we use something called a switch. So what a switch does is we declare a switch, and we use a set of parameters. Now the parameter is the variable that you want to test. So we're going to be testing this variable for a value, for any type of value, and as you'll see, you can see what will happen when we test these different values. So once we declare this, the switch, we put a body, and in the body we put case statements. So what a case statement is it basically says, in case of this test, or in case of this value being inputted, or in case of something this happens, then this program or this set of rules will run. And to do this, we put case, and then we put in case of what. So in case of a string, we put something inside our brackets right here, but we're using a number, so we're gonna say in case of 1, and then we use a colon to separate our code, and then we just say what happens in case of 1. So in case of 1, we're just gonna say cout, you lose. So if the user enters 1, it'll say you lose. And we can say in case of 2, and on and on and on. So you just say in case of 2 what will happen, and of course we can do many things with this. So I just don't want to explain the basic concept of it. Actually, what we're going to do is create a little program using the switch branching. So we have these two, and we're testing the variable for number. So when the user inputs a number, we have this switch statement that's going to pop up, and it's not going to pop up to the user, but the program is going to say, okay, if the user enters 1, then this, and if the user enters 2, then this. And of course I could have used any other numbers and kept going with our case statements, but we're not going to do that right now. What I'm just going to do is just go ahead and prototype our function, and we're going to run it. So enter a number, and I'll put 1, and there you go. So in case of this, actually, okay, so we get both of these statements, and the reason that this happens is because when we got the when we end these functions right here, we have to have the break. So what a break means is that when these statements are done, these case statements have to be separated by something that tells the compiler, okay, I'm done with this case. And I'm sorry for not mentioning that earlier. I sort of forgot, it slipped my mind. So we have to separate these with breaks. So if I was going to carry a case 3 and cout whatever, We just have to separate each one with brace or a break sign. So we'll go ahead and run this again, and where it says enter a number, we're just gonna enter 2, and there we go, you win. And that way we don't get all the values at once. The compiler knows that this is one case statement and it's separate from this case statement and it's separate from this case statement. So that's basically all I wanted to show you guys. There are a few other things that we could go over within this, but I'll leave that for later on because you have to use a few functions that haven't been introduced yet. So we'll wait for that, and just please subscribe to the channel and like and share the video and give me a thumbs up. So thank you guys for watching and have a good day.